Good afternoon. I hope everybody is fine after 1.5 days of a lot of fine food and a long party. And if you are a little bit tired, this is no problem because we have now a wake-up talk by Martin Jons.
Yeah, sure.
And he will give us a kindly introduction into the arms race of clickjacking. It's about clickjacking, clickjacking countermeasures, clickjacking countermeasures.
I might go into that. We see if I sufficiently will fulfill your hopes.
Okay, and I hope you will tell us at the end of the talk who will win.
Yeah, awesome.
It's a good side. Thank you. Martin.
Yeah. Okay, so if you have looked in the program, you saw this name. And Sebastian is a colleague of mine, and this is mostly actually his work. So it was done with some collaboration by mine. But so the most technical contributions come from him, and therefore, and I'm only here last-minute replacement because he had to leave Hamburg on Wednesday evening because of a family emergency. So for one, we all should wish him luck and strength. But also, everything that is good about this talk should be attributed to Sebastian. Everything that you don't like is because probably I didn't understand it correctly, I didn't look at the slides good enough, or I screwed up. So with no more introduction, I will talk about clickjacking. And so it's a very simple agenda. I will tell you about clickjacking. I won't go into all the details and nitty-gritty stuff that you could do with details and attack variants. If you're interested in that, we have, I think, probably at least Europe's, if not worldwide, the clickjacking expert at this conference, Markus Minitz. Try to find him. Ah, there he is. Hello, Markus. So every time I say something wrong, just raise your hand and correct me. Then I will talk about a little bit of current defenses that we looked at and some issues and limitations and stuff that we didn't like about the current defensive approaches that we encountered. And then I will present you how we think it probably currently makes the most sense to do clickjacking protection. And then again, Markus will raise and say, this is crap. Good, let's talk about what is clickjacking. So clickjacking is also known under the a little bit more academic term UI redressing, and is in general the blanket or umbrella term for all attacks that somehow lure the victim into interacting with a web UI, which is rendered in a somewhat security-sensitive or authorized state. And the interesting part is that the victim that interacts with this UI component is not aware that he's actually doing this interaction. So how is this working? So we have a browser. As we all know, browser keeps states using cookies. For example, this browser has a session cookie or authentication cookie from a site called mybank.org. But he's not at mybank.org, but he looks at the site attacker.org, which probably is showing some funny video or some cat pictures or some good games or whatever you want to do in the internet when you're actually enjoying your life. And what he doesn't know is that attacker.org is able to instantiate what we call controllable containers. This is mostly iframes, but also we will see it can also be pop-up windows. And these controllable containers, for example, this iframe, is instantiated in the context of the site attacker.org. But as it is instantiated in the browser of the user, it gets the state, the authenticated state in this case, of the user of the browser, and therefore the UI is rendered as if the user might want to do something sensible with this interface. But as this iframe in this case is rendered in the context of attacker.org, the attacker is now able to apply, for example, CSS to the iframe element, or to do some overlays with his own elements over this thing. So you can do various steps to disguise or to make the bank.com UI invisible. Again, if you want to see all the details on how you can do this, refer to Markus. And what he's then doing is he's either overlaying the disguised UI with his own fake UI, or he doing an underlay, depending on which technique he's using. But now for the user, it seems he only sees the content that the attacker wants him to see. And the attacker also provides some incentive to interact with this fake UI. And if the user now clicks on this button because he wants to win a free iPod, because we all want to win a free iPod, he actually would do something with his bank, maybe transferring some money, closing his account, or doing something else that you actually don't want to do and you're not aware of. So how do we pretend again, or how do we defend against something? So there are client-side approaches. So there's the clear-click protection measure part of the NoScript Firefox plugin called ClearClick that provides a client-side protection. But as I'm from SAP, I'm more interested in what could a company do to defend their users against this attack pattern. Therefore, from now on in this talk, we will look only at server-side approaches. And there are in total 2 approaches that you could use today to protect your application. So either can use frame busting, and we'll talk about frame busting in the next slide, or you can use the now almost standardized X-frame options header, which will be in 2 slides, I guess. Good. So frame busting. Frame busting was the premier and still often encountered way to defend against clickjacking. So how does frame busting work? Frame busting has the basic idea that if I'm bank.com, I simply forbid that I want to be framed by some page with kitty pictures or something else. So, and how is this implemented? It's implemented with a very small but powerful JavaScript, because JavaScript, so this script is rendered on, in this case, the bank side, and before anything else is happening or some UI is rendered that might do something interesting with the page. The page itself checks, am I in an unauthorized framing context? So is somebody trying to frame me because I don't want to be framed? And if this is the case, so if this check fails, then navigate the current parent document or the top document, hopefully to my own, so bust out of the frame. So this is in general a rather sensitive approach. Unfortunately, over the time, people much smarter than me have hit on this or evaluated this approach and found several ways around, let's say, naive frame busters. So for one, the attacker can try or can attempt and also can succeed in preventing the execution of this frame busting JavaScript. So a fun way to do this is, because it's always fun for attackers to use security functionality to do something which makes the site more insecure. So one of the things that you could do as attacker is trick cross-site scripting filters, for example, from Internet Explorer or from Google Chrome, to think that this little JavaScript that is supposed to protect the site against framing is actually there because of a cross-site scripting attack. So you can do this mostly if you just take this script and append it to the URL, because then it looks like it is part of a reflected cross-site scripting attack, and the cross-site scripting filter will disable the script, and therefore the site will be framed. Also, you can use nice HTML5 features like sandbox iframes and forbid the framed site to execute JavaScript, and boom, again, the site is framed. Also, there are a couple of techniques that I won't go into details that could prevent the redirect step. So the second step, so the first step is here, check if I'm framed. The second step is redirect the site to somewhere where we control everything. So if the attacker prevents the redirect with something that's called 204 flushing, with something that is called double framing, or by using the before unload event, then the frame buster again fails. So it's possible to create secure frame busters. Look at how Facebook does this. I think they have a rather good solution. There's also a paper by some Stanford guys, Colin Jackson, Adam Barth, if I'm not mistaken. They propose a good frame buster. So you can do this, but you have to be rather careful and really know what you're doing. The better way, TM, to do this is using browser features. So we have now in all major browsers the capabilities to recognize a HTTP response header called X-frame options. With X-frame options, the site that is delivered to the browser by the server, so the server can tell the browser, okay, this is how I allow framing. And there are 3 levels of granularity. So this, the server could say to the browser, I deny framing. This site is never allowed to be framed. Nobody is allowed to frame this page. If this frame is accessed or is rendered in an iframe, simply don't display anything. Then also you could say, okay, I allow SIAM origin framing. So if Google wants to frame a site from Google, then this would be allowed. IE does something sensible. They also allow a directive called from origin. So where I could say, okay, my site is scp.com, but I would allow rrecord.com to frame me because we're good friends, and therefore I trust them to do something sensible from my side. But attacker.org wouldn't allow this. Problem is from origin, two problems with from origin. For one, it's not cross-browser. So it's, I think now 2 of the 4 major browsers recognize this, and at least one doesn't. And the bigger problem is the browsers that don't recognize this fail insecurely. So if they see a from origin and they don't understand from origin, then they allow framing. So this is something that we currently can't use, which sucks. But if you never want to be framed, deny is a good thing to do. So let's come to the open issues and limitations that I promised, and also that we want to work around at least a little bit in our protection approach. So the first problem is, as we just saw, that all protection mechanisms that we just saw consider clickjacking attacks that work with iframes. Unfortunately, clickjacking is not limited to frames. So there are 2 techniques. One is called double clickjacking, and the other one is clickjacking by history navigation. And let's look in the first one. Double clickjacking was firstly documented in public by Hung and Jackson, I think from CMU Silicon Valley. And double clickjacking is based on pop-ups instead of frames. How does this work? So the attacker opens a pop-up window, or more a pop-under window, behind the current browser window in which the UI that is supposed to be the target of the clickjacking attack is rendered. On the opening page, receives this window handle, and therefore can also do navigation control on this side. In the next step, for example, with a game or with some other social engineering, the victim is tricked to double-click on the attacker's page, because we have now the situation, we have 2 browser windows, we have one browser window rendering the attacker page, and one browser window rendering the page that's supposed to receive the legitimate click. If the attacker succeeds in tricking the guy to double-click a certain location, because also there are some rather stable assumptions where the pop-under window will end up in respect to the parent window. And they did some very good experiments on this. There's a Usenix paper on this topic. So the first click hits the attacker's page. He receives the click, he closes the page, or he puts the window into the background. And the second click, because click, click is so fast that the user usually can't stop the second click, hits the pop-up and triggers state-changing engines. And so as the pop-up receives the first click, afterwards it can be closed by the parent window because we have navigation and control. And they documented successful attacks, for example, against Google Auth authentication pop-ups, where you then could grant arbitrary rights to arbitrary sites on Google sites via OWASP. The second attack is very similar, but works a little bit different, was documented by Michael Zalewski, is based on history navigation. How does this work? So the target page that is supposed to be clicked is opened again in a pop-up window. It's loaded, it's rendered, and then we have the page in the cache of the browser. Afterwards, the pop-up is navigated by the attacker to an attacker-controlled site. Now we have this victim page in the cache, and therefore, if we would navigate back again to this page, for example, by using history back, this page transition will be very, very fast, because our modern browsers are very, very fast, which we are very thankful for. But this could be used against by the attacker. The attacker now has in this pop-up window a site that is controlled by him, and then he can again have some social engineering game. So click this mouse and click here and click there and click there and click, and between the second to last and the last click, the call history back navigation has happened. The victim side was loaded and the click is received by the victim. Again, clickjacking without frames, kind of sucky. So much about clickjacking attacks that don't rely on framing. Furthermore, we looked into the current state of the implementation of the X-frame option setter, because we wanted to know, is this something that we can tell our developers to use safely, and if you like it. And we found 2, you can tell them vulnerabilities, limitations, open issues, fringe issues. Make out of this what you want. So the first thing is we looked at the offline application cache of the various HTML5 capable browsers, and Safari, and especially mobile Safari, is one of them. And if you look into the mobile space, the application cache is actually used quite a lot, because there every byte is expensive and slow, and you want to cache as much as controllable as possible. But what we noticed, well, every site that is or every page that is loaded into the HTML5 application cache in the Safari browser loses more or less all its header state. So there are some limited headers that are cached, but most of the headers are disposed. Therefore, the great X-frame options header is not persisted in the application cache. Therefore, if we have a case where we want to do a click-checking attack on a site that is cached in Safari's application cache, there's a good chances that when the site is loaded in an iframe, it actually will render, because it is retrieved not from the network where the response header would be available, but it's actually retrieved from the application cache, and in this case, so the X-frame options header is not there, and therefore it will be happily rendered by Safari. So we checked this both for desktop Safari and also more significantly for mobile Safari, the major browser, the one true browser on iPhones, iPads, and everything, and I think Google TV. And so we consider this to be bad. And also if you look at CSP, I wouldn't be surprised if CSP headers also are discarded on caching. The other thing is, I think is also rather, for some people know this for a while, but it seems to be more an issue that's not supposed to be fixed. We call it nested clickjacking. So how does nested clickjacking look? In nested clickjacking, we have a framing hierarchy. So we have the top document is victim.com. So the site that we also want to be part of the click, that want to be targeted by clickjacking. And for some reason, and I will go into the reasons, the victim has a frame to a site that the attacker controls. And the attacker, again, opens another frame in this hierarchy, pointing again to victim.com. So what we learned is that if you have an X-frame options same origin, something that, for example, Google deploys frequently, then for some reason, and maybe we want to ask Dave Ross about this, why is this is the case? It works so with all major browsers. For some reason, the same origin is only checked against the top level origin, top level document. But as we can see in this hierarchy of frames, we have an untrusted origin that is not same origin. But still, if you try this, you can see, so we have here, this is a website that we control, and we have an iframe to google.com, and obviously it's not rendered because of X-frame options. But if we access an image that is on this site with Google Images, then Google Images opens a preview iframe to our site. So this you can see we are on Google.de. We have an image that is hosted in this case on the site, and our site in the iframe has an iframe to Google, and it's happily rendered even though the X-frame options header is there. So then you can again argument, why would a site that wants to protect itself allow an untrusted site to frame a site that again frames it? So is this a realistic attack? And then I would like to remind you of something that you see often. These are ad providers. And ad providers usually show their ads in iframes. They render content that they don't control themselves, but everybody that has enough money can say, hey, put this in the iframe on the site that you, on certain amount site. And also these iframes tend to be interactive, so they want you to click. So I'm not sure if you click on ads, I don't, but if you click on ads, you actually might not click on the ad, but on a click-checking attack. So final open issue, and the one that was actually the motivation for the last part of the work that we will talk about. We saw that the current defense mechanisms have all one thing in common. They prevent unauthorized framing. And so you can do same domain framing, but you have to forbid cross-domain framing, mostly because the allow from directive is not sufficiently supported. The problem is in enterprise settings, especially stuff that we build with SAP, there are numerous situations where we have, for example, intranet sites, intranet portals, but also some other sites that need to be framed by our customers. They need to be, because they want to use the SAP applications as part of their UI in their intranet. And therefore, we can't forbid cross-domain framing, because then we will break the sites of our customer, or the applications of our customers. And there are more things where you want to do. So web widgets is a good example where you want to at least allow some limited cross-domain framing. Ad providers obviously need this. And so with the current aims, especially with the current instantiation of the X-frame options header, this is not possible. Good. So in the last couple of minutes of this talk, I will quickly present you what we came up with, which is something that we currently think is, at least until we have, so there, let me, before I go into there are obvious better things on the horizon. Thomas Röser can tell you everything about this. So there will be something called UI safety directives to CSP. And if we have this, clickjacking is probably more or less solved. But until we have this, we have to help ourselves, because browsers move swiftly, but not swiftly enough. So what's our protection approach? So we have a couple of design goals. So we want to be based on standard browser features so that everybody can use this, because otherwise, what's the point? We want to be as broadly applicable as possible. We want to be able to protect as broadly as possible. So we want to both be able to protect against the text that consider frames, but also at least attempt to protect against these pop-up attacks that you just saw. And also, we want to be configurable, because we have the business need to be cross-domain frameable, so there was supposed to be some solution in that direction as well. So we want to maintain a whitelist. We want to say oracle.com is able to frame sap.com, and hp.com is able to frame sap.com, and cccde is able to frame sap.com. And so how shall we do this? We do this with a whitelisting approach. And so as we can't change the browsers, we have to use JavaScript. And so what are our challenges? So let's start with the idea. So the general idea is that, so also rather obvious, whenever a site attempts to render our page that is outfitted with our mechanism, the framing side, or the opening side, and the owner of the untrusted container is supposed to prove something about its identity. And only if the identity, the origin of the site is in the part of the whitelist, the web page itself is allows UI interaction. If not, all UI interaction are postponed. So what's the challenge? So we need to prevent rendering of the page. This is rather easily done. This is something from the Stanford paper. So we simply use CSS to disable any UI interactions, for example, with display none. There are other techniques. You could use some overlay, or you could use, there are several techniques, but this is the shortest one, so it fits well on a slide. Next thing is you detect if you have an untrusted viewport constellation. So you check, again, from the frame busters, you check, okay, am I framed? And also you can check at least, and this is one of the limitations of our solution that we can't solve, we can check if we are opened in the pop-up window. We can't check if there's a window that we have opened. That's kind of sucky, but at least in one direction we can check if somebody has navigational control over our site. And if these tests fail, the embedding page has to prove that they are on our whitelist. And for this, we use the fantastic post message API, which is part, I'm not sure if it's part of HTML5, but it's part of modern browsers, which has some nice capabilities. The most interesting capability is, for one, it allows cross-origin communication. And this cross-origin communication works in a way that the event origin, so the site that is sending this message, can't be spoofed. So when I receive a post message, I will always know, and the browser vouches for the authenticity and integrity of this information, who was sending me this. And all we need now is the framing side needs to inform the frame that he's actually the framer. And then we can say again, okay, we answer then, okay, yes, you're allowed, you can now do whatever you want with the frame. So does this look? So we have the embedding page, and it first registers some post message, then the page is framed. It's not rendered yet. Then it says, okay, now you can send me the post message. The framing page says, now, dear frame, enable user interaction the site can receive the post message, can say, okay, what is good, and renders UI in case that example org is really on the whitelist of framepage.com. Otherwise, it just dies or does something else. Good. Just in time, 25 minutes. Here's the conclusion. So clickjacking, I told you about clickjacking. I think you all knew about clickjacking anyway. I talked a bit about the protection approaches. I told you what we found in respect to limitations and current implementation glitches of the current protection approaches. Then I presented our new protection approach. I hope it was somewhat understandable. If not, approach me afterwards. I'm happy to give you the executive summary again. And yeah, with this, if my remote allows me, I'm able to answer questions. Yeah. Mr. Manico. All of them. Okay. Oh, you good now. So the question was, what kind of browser support do we have? So the short answer is all of them. The long answer is we support every modern browser that has the post message API available, which is pretty much everything that you find in the wild world, minus something like 2%. With the pop-up communication with the pop-up window, we have issues with IE. That might be, we could go around that or not, but as our pop-up protection is incomplete, to be honest, it's not on a high priority to fix that. I don't think so. IE6 doesn't support post message as far as I know.
I have a suggestion. Can you click on that to give you IE6 support? I'll talk to you right after.
Yeah, you're my man. Mario.
I have a question. I have the feeling that the check is a little bit too strict. So you want to find out whether the page that is possibly endangered is being loaded in a pop-up, and you use opener. But if you, for example, have like a link element and you have like target blank or target something, then the loaded page will also have an opener object. So how can you make sure that your tool is not too strict in this situation?
If we fail on the side of security, I don't have a headache. The bigger problem is that we only see if there's a page opener. So if we are actually the page that opened the window, and there's the uncontrollable viewport constellation, then so the protection against the pop-up windows is the best effort. It's not bulletproof. So
we actually worked on the same thing some time ago, and this opener thing actually broke our neck. Yep. So we realized that we were protecting against too many things at once because the opener object as such is not a clear indicator whether there's a pop-up or if it's just a new tab that is opening. And the new tab is clearly not an attack or extremely hard to be instrumented in an attack.
Yeah.
That's what I was wondering.
It sucks. So.
Okay. Maybe you could have found something that we didn't find. So.
I wish. We looked hard. But if you didn't find anything, then we at least don't feel bad about that.
Looks like interesting protection, but what I want to say is that it will be much better to improve inbuilt support, inbuilt protection like extreme options in browsers against to make yet another protection with JavaScript, because now, for example, every developer needs to think, oh, okay, I need to add such kind of JS here or something like that. It will not work.
Yep, I agree. This is currently, I think Boris made it very clear. So this is just another addition to our current arms race, and this is not the way that I'm also an academic. As an academic, say, don't do this like this. Wait for the browsers to have something good. And there's something very good on the horizon. So we will have something. Thomas, what's the real name of the CSP thing? I think I budgeted. We have an addition to CSP that does some UI safety directive. And if this comes into the browsers, we can work with this, and this should work for most cases.
It is CSP directives for UI safety, I think. It is w3.org/tr/UI safety, and I actually tweeted it a minute ago.
So we will retweet it.
Hi, this is Tobias Gondrom. Thanks very much for pointing out the deficiencies we have with extreme options. And just to add on one thing, actually the current way we standardize it right now is it is deprecated. So this is documenting what is out there. This is not claiming this is the solution. Specifically, we point towards the Content Security Policy 1.1, which will include the functionality that you're asking for. And in 1.1, we will also not have this nesting problem. So in this case, we're actually going to check every instance. I mean, you're totally right. With same origin, we point towards the top level, which is, yeah, not the smartest way. Thank you.
Thank you. More good news.
Yeah, Martin, thank you very much for your introduction into the frame race.